All right, back to page 10, and we are looking at these situations with parentheses, exponents, and negative numbers. So when we have an even power, it's going to behave differently than when we have an odd power. And actually, the odd powers are, easier, in easier situations. So let's look at the even powers here and see what's happening. So with the parentheses, remember that means that entire chunk is being squared. So I want to think about it as -8 times -8. And we have two negative signs there, so they will cancel out, and that will be positive 64. Now, if it has the negative but no parentheses, remember that we're going to be thinking about this like -1 times 8 squared when I'm thinking about order of operations. So I make sure that I'm doing the exponent and then multiplying by -1. So this one will be negative. And it happens when we have the even powers. That's the tricky situation. So if it was an exponent of 2, an exponent of 4, 6, and so on and so forth. Because we have the situation where if we have an even number of them and we're doing the whole chunk that's in parentheses, those negative signs are going to cancel out. Don't cancel out here. With the odd powers, so think about if I have the -8 cubed, right? So that'll be 3 of them. And 2 of those will cancel out as far as the negative signs. So we end up with negative, and what is that, 512? Let's see here. Yeah, 512. Negative 512 for this one. For the other one, thinking about that in terms of a -1 times 8 cubed, so we think about our order of operations properly, then we'd have -1 times 512, which would be -512. So you'll see here that these are the same. For the odd power, they are the same, but for the even power, they are different. And this is the thing that will throw people off if they have a complex order of operations problem, things like that. So make sure that you're getting that idea of if it's an odd power, then it's going to stay the same. So it really doesn't matter which way we think about it. But with the even power, it's really important to think about how is it that order of operations is happening here in order for me to get a positive value here and the negative value here. And we can think about that same thing with -1 as just an additional example. So when I have the parentheses, so I'll the whole chunk, and it's 2 times because it's an exponent of 2. So +1 would be my answer there. And for this one, think about -1 times 1 to the 4th. And that would just be -1 times 1. So this one would be a -1. So one way that I kind of summarize this is if you have an even power plus parentheses will give you a positive value. So all those P's in there. Even power plus parentheses, positive value. Now, if you have something like the opposite of -8 quantity squared, now that's going to be a different thing because we're throwing an additional negative sign in there. So that's not going to be, you can't use that as a blanket for that. But this is what I'm talking about is this situation. So I have like the opposite of b squared. And then that would just be b squared, not the -b squared. All right, I'm going to pause for a second to flip pages here. Continuing on page 11. So dividing now these real numbers and remembering that just like with multiplication, if the signs are the same, we'll have a positive answer. If the signs are different, then we'll have a negative answer. So 60 divided by negative 3, they're different, so it'll be negative, and then 60 divided by 3, 20. Negative 56 divided by negative 8, so that'll be a positive answer, a positive 7. Negative 15 divided by positive 5, so negative because they're different signs, and then a negative 3. And then the next 3 are, one is a little bit different way of looking at it because we're, we've got the old division symbol there, so negative 84 divided by negative 4, so they're both negative, so I'll have a positive answer, and then that will be 21, positive 21. And then these last 2 are those special cases that occur with 0. Remember, 0 and 1 always kind of throw off the rules. They're the exceptions all the time. So think about this as, remember, 0 pieces of pizza out of a pizza. So this is just going to stay 0. That will be 0. Dividing by 0, undefined. So this one, undefined. Not have 0 in the denominator. That you're going to have that, if you don't understand specifically why we use the word undefined with that definition of multiplication and division that I showed you earlier, don't worry about it. Just remember, you can't have the 0 in the denominator. That's the undefined situation. 0 in the numerator, no problem. That's just 0. But 0 in the denominator is not all right. All right, a couple of little word problems here going with our different operations with integers, addition, subtraction, multiplication, division. All right, so Jennifer's checking account had $320 when she wrote 2 checks for $150 and 1 check for $82. What is her new balance? All right, remember that if you are in a place where you can, that reading story problems out loud will help to clarify them and kind of start organizing the information that you're going to have. Your brain forces you to kind of figure out better what it means if you're reading it out loud so that it has meaning. So I highly recommend it. They've actually done studies on this. This isn't me just like making stuff up. So I'm going to start with $320. She writes 2 checks for $150. So, okay, so 1 check would be $150. I'd subtract that off. And what? Get $170. And then I subtract off another check for $50. So $150. So I end up with $20. But now we're subtracting a check for $82. All right, so that is this situation where I've got 20 plus a negative 82. So, she is overdrawing her account, right? She's got $20 in her account, but she's taking $82 out of it. So she's actually going to end up in the negative situation, which hopefully makes sense because this is a money thing and you can't take out money that you don't have. So we'll have a negative value here and then subtract the absolute values to figure out what that will be. So 62, so negative $62 is her current balance. Next one. When a severe winter storm moved through Albany, New York, the change in temperature between 4 p.m. and 7 p.m. was negative 27 degrees Fahrenheit. What was the average hourly change in temperature? Okay, so we want hourly change in temperature. So, in other words, we want degrees per hour. So we want to figure out how many degrees we changed and how many hours that happened over. And then we divide them to get the average. Because remember, the average is the total divided by the number of items, right? If we have like pieces of candy and we want to separate them among our class. Then we'd figure out how many pieces of candy we have total and divide by 27, and that would give us an average number of pieces of candy per person. So, all right. So looking at this, the change in temperature was negative 27 degrees Fahrenheit. So that's going to be our degrees. So negative 27 degrees Fahrenheit. And then it's in the hours from 4 p.m. to 7 p.m. So that's a 3-hour span of time. And then we just have to divide this and put the appropriate label on it. So the label is going to stay degrees per hour, which is what we want, right? That'll give us our hourly change in temperature. And the negative 27 divided by 3, just think about that, will be a negative value because they have different signs, negative 9. And then that would be degrees Fahrenheit per hour. Yeah, it might look a little bit nicer if I wrote it like this. It would be another way to write the label, so hopefully it's a little less confusing. Okay, and that should make sense, right? If I go from 4 to 5, if I go down 9 degrees, and then I go down another 9 degrees from 5 to 6, and another 9 degrees from 6 to 7, then I would get to a total of 27 degrees that I have gone down throughout that process. All right, I'm going to pause for a moment to switch to the next page. All right, continuing on page 12, we're going to kind of think through these situations here. So what number must be multiplied by negative 4 to get negative 36? So we have a negative number and we want to end up with a negative number. The only way we're going to have that happen is if the signs of the two values are different. So if I have negative 4, I'm going to have to multiply that by something positive to get to a negative 36. Otherwise, these signs would be the same and we'd get a positive 36. So I've got to do a positive something. Well, and then I have to think about, all right, well, what would this be? So divide 36 by 4 and we get 9. You know, another way to think about it is what times 4 would give us 36. So we're going to have 9, and then it has to be a positive 9 in order for this to work out, where we started with a negative number, but we still end up with a negative number after multiplying. In the second situation, we are starting with negative 4, but we want to figure out what's going to go in there to get us to negative 36. It's still going to be 9, because 4 times 9 will give 36. That'll get the numerical part right. But to get the signs to work correctly, oops, now this is supposed to be positive 36. Haha, sorry. To get the signs to work out properly, we've got to put in a negative value there so that we would have a negative times a negative will give us a positive. So a negative 9. So if I do negative 4 times negative 9, then I would get to a positive 36 for that. All right. This is a good spot to stop, and I will work on getting this uploaded on the next video. One moment.